Dear nephrology colleagues, my name is Peter Stenvinkel, and I would like to welcome you to this e-seminar on behalf of myself and Professor Annette Bruchfeld. Today we will discuss green nephrology and what does it mean and why is it necessary to reduce the environmental impact. Our planet is 45 million centuries old. But this century is the first in which one species, and that is Homo sapiens, which actually means the wise man, can determine biosphere's fate. We are seriously unsynchronized with the rest of nature and the planet. And nephrology, like all medical specialties, must now evaluate their activity in relation to sustainable development goals. And I would believe that kidney, more than any other organ, has a critical role in protecting the body from rising temperature through its ability to control water and electrolyte balance. So nephrology should take a special interest in the effects of global warming on health and its potential to cause acute and chronic kidney injury and severe dehydration. And with this, I would like to introduce the first speaker of this e-seminar. That is Professor Peter Blankenstein from Utrecht University. He has many different interests, including hypertension, treatment and prevention of complications of chronic kidney disease, diverse hemodialysis techniques, and vascular access. But today he will talk about medical pollution. Please, Peter.
Okay, thank you very much. Yes, please. Okay, so I will share my presentation. Okay, well, Peter, thank you very much for your introductory words. Indeed, I'm a nephrologist working in the University Medical Center in Utrecht, and with respect to this presentation, I have nothing to disclose. I will start with a few personal words. I'm not a traditional environmental activist, but I have to say that I have become one over the past few years, and several issues have led to that situation. And one of these is this paper, which appeared about 3 years or so ago in the Landsat Countdown on Health and Climate Change from 25 years of inaction to a global transformation in public health. And one of the key messages of this paper is that the interaction between health and disease and our environment has two directions. And by that, the authors meant that there's an effect of the changing environment, a detrimental effect on health and disease. But the other way around is also true, that we as a healthcare sector actually contribute to this pollution and this change in environment. And especially that last, the second interaction, is very much in conflict with one of the primary themes or values in our profession, primum non nocere, first do no harm. And when I realized that these authors were actually quite true, I thought, well, I should focus more on this subject. So here again, these two interactions, and the first interaction will be the subject of several presentations in the next webinars. So in the coming couple of minutes, I will focus on what we as a sector actually do on the environment. So I would like to start with presenting this report, which was released about 1.5 years ago or so, on the how the healthcare sector contributes to the global climate crisis. And this is a global picture on the carbon footprint of the healthcare sectors all over the globe. And the special thing of this report is that it really gives a global picture using the same methodology all over all countries, for all countries. So that makes comparison between countries and regions possible. It will probably not surprise you that the United States, China, and we as European Union are the biggest contributors to the global carbon footprint. And if the healthcare sector was a country, it would be the 5th largest emitter of the planet. So probably more interesting is the healthcare emission per capita of country by country. Then the top emitters are Australia, Canada, Switzerland, and the United States. And many European countries are listed as major emitters or higher than average emitters. But also this list contains actually quite interesting information, because countries like Sweden and France and Spain have lower emission rates as compared to other European countries like Germany and the country where I live. So it would be interesting to understand how these differences can be explained, because the quality of healthcare is more or less comparable between these countries. So the question, of course, is what kind of activities actually contribute to that global picture, to that total carbon footprint? And actually, this is a very nice paper in this respect, which was released a couple of weeks ago on the healthcare emissions by the NHS, the National Health Service in England. The National Health Service is the single largest single-payer health system in the world. It's created the Sustainable Development Unit more than a decade ago with the purpose to meet the government's commitments. And they have estimates on its carbon footprint over a period of almost 30 or so years. So they apply 3 scopes, and scope 1 is the carbon footprint caused by the delivery of care itself. And the scope 2 is the purchased electricity to do actually scope 1 activities. And scope 3 are materials and goods and services purchased to do scope 1 activities. And on the right side, you see that this supply chain, so the scope 3 activities, is responsible for about 2/3 of the carbon footprint, and about 1/4 is making the scope 1, so the actual delivery of care. And within this supply chain, pharmaceuticals and medical devices are make big contributions. So over these 30 years, they managed to actually a little bit lower their total carbon footprint. So this is the total greenhouse gas emissions for England, for the National Health Service. And this is the per capita effect. So over the 30 years, per capita, there was about 30% decrease. And actually, this decrease is explained by a small decrease in almost all of these activities. So there's not one single change within all these activities I showed you on the previous slides, which explains this decrease. So 30% decrease is, of course, nice, but not enough given the present ambitions of our globe. And indeed, they published this report a couple of months ago, defining very high ambitions for the coming years. And they state, for emissions that we can control directly, we aim at net zero in about 20 years from now, with an ambition to reach an 80% reduction already in 2028 so in about 10 years from now. And for emissions that we can influence, the emission level is a little bit lower. And the reason why I show you this is that on a country level, I think the United Kingdom really has a front line position in defining ambitions for the healthcare sector. So if you narrow it a little bit down, so we did a similar type of analysis for the institution where I work, University Medical Center in Utrecht, which is a teaching hospital with about 11,000 employees. So the carbon footprint of the delivery of care is this number. And for the purchased articles, so the scope 3 activities, is indeed about 3 times bigger. So also on our institutional level, you see a little something like a 1-to-3 relation, as was seen in the National Health Service as well. And the biggest contributions in our hands is medication, energy, transport of patients and employees, implantates, disposable and diagnostic materials, and food. So very comparable to the data of England. So what can and should we do? Well, we all know that the ambition of the European Commission is to accelerate the transition to a sustainable society, and that is top priority number 1. And given the fact that the healthcare sector is part of society, we should be part of this transition. And I think then it is important to realize actually what the definition of sustainability is. And often this definition is used from the Brundtland report. Mrs. Brundtland was the Prime Minister of Norway in this period, and she and her committee made this report and produced this definition. Sustainable development is a development that meets the needs of today without compromising the ability of future generations to meet their own needs. And if you really think this over, this definition is still very appropriate. So we in nephrology, so the next couple of slides I will focus on nephrology. Actually, there's no such analysis as I've shown you from the National Health Service. I mean this scope 1, 2, or 3 analysis. But I will summarize briefly what is known. And I think it is correct, it is appropriate to give credit to Australian colleagues who are already trying to put this on the agenda for a decade or so. And this is a very nice review published a year ago or so, summarizing the available data for nephrology care, very much focusing on dialysis. And I have to say that the short summary is that there's only little data. And an interesting study is published a couple of months ago from Fresenius centers in France, who did an analysis on 3 variables of dialysis. So electricity consumption, water consumption, and waste production per session over a period of more than a decade. And they describe how they were able to reduce these 3 key performance indicators over that period of time. And these are the numbers for their latest year that they report, 2019. So if you take these numbers and do a few calculations, and that is shown on this slide, given the fact that we have 333,000 dialysis patients in Europe, and you take these numbers, then that translates to this kind of pollution, this kind of environmental burden. So about almost 8,000 Olympic swimming pools of water, so that's 22 pools per day, we use for hemodialysis, and the weight equivalent of an adult elephant, almost 10,000 elephants, and the energy consumption of a city of almost 1 million people, or this number of kilometers in an electric car. I can even not pronounce this number. And then please realize that this is only the scope 1 and a little bit of scope 2, a kind of environmental burden, and not taken into account the scope 3 factors. And when you would extrapolate this on a global level, then this need to be multiplied by 9. So already a couple of years ago, the EDTA decided to put this on its agenda, and these are 3 editorials explaining why we think that that is important. And indeed, also on the coming meeting in Berlin, topics related to sustainability are included into the program. And this latest editorial, which was published alongside to the study of the French Fresenius centers, also included this table with some clear suggestion what dialysis staff of any center could do, what we could expect from the dialysis industries and dialysis provider chains. So create awareness and implement a program of monitoring and reporting relevant variables, such as waste production and water and energy consumption, and define activities to reduce these variables. But also express expectations to supplier industries to help to reduce, reuse, recycle, and refuse, and consider environmental burden when choosing new equipment. So start a discussion on circularity of equipment. And similar type of task could be expected from the industry. So innovate and develop materials of equipment with lower impact. Accept co-responsibility on the fate of equipment. So start thinking about circularity. Develop programs to address that, and develop learning programs, for instance, together with us, with the EDTA, to do that. And the same actually apply to the big provider chains to share their experiences, and such like these Fresenius data published in NDT with the field. So, and on a personal level, you could also be active. So asking yourself, is there a sustainability policy within your country with respect to the healthcare sector? And within your institution, is there personnel specifically addressing that, specifically responsible for that? Is there a sustainability plan policy? Are there targets? What about your department? And with respect to dialysis, do you have information on these 3 variables I just mentioned? When choosing materials, take this into consideration and expect a plan of the manufacturers and the suppliers with respect to circularity. I would suggest start a movement, commence action, and introduce this subject in all levels of education. I think we as professionals can be active on 3 levels. Many of us are active in care, research, and education. And in all these 3 focus areas where we are active, we can contribute. And indeed, I think that together we can make the difference and contribute in making good health and well-being, quality education, responsible consumption and production, and climate action. So addressing at least 4 sustainable development goals. And I've submitted this idea a couple of in the first issue of this year of Nature. So that brings me to the last subject to discuss, and that is education. What is actually sustainable healthcare education? That can be defined as teaching and learning which prepares the future health professional to promote sustainable health and to deliver sustainable healthcare. I had the privilege to co-author a paper on that, published a couple of months ago in a journal which actually beforehand I didn't know, the journal Medical Teacher. But we proposed 3 recommendations related to values, knowledge, and skills. And this was taken even further in this comprehensive consensus statement, which was published about 4 weeks ago of the Association of Medical Education in Europe. And they state that so in order to reduce emissions and meet the Sustainable Development Goals, health professions, education to undergraduate, but also those already qualified, need to equip with knowledge, skills, values, competence, and confidence. They need to sustainably promote health, human rights, and well-being of current and future generations while protecting the health of the planet. And this is a very comprehensive paper. You see 15 patients. It really goes in very much detail how you can start up a educational program. So it could be helpful in your practice as well. So this is my one before last slide. So I think it is important to realize that the interaction between health and disease and the environment has 2 directions. And my moonshot vision is that sustainable health and sustainable health care should be mainstream, business as usual, part of everyday practice. So it's not special, it's not extra, it's not extraordinary. No, it should represent a new normal. And we as medical professionals should be key players in that journey towards that moonshot vision with a focus on care, research, and education. And I think we should show leadership and focus on resilience. So by that, I mean how to counteract the negative effects of the changing environments on health and disease, and mitigation. So how to reduce our impact on the environment. So, ladies and gentlemen, my professional drive to do this, I hope you have sensed a little bit of activism in my speech. And
thank you very much, Peter. So this is Annette Bruchfeld, and I have the privilege to introduce our second speaker today, who is Jitka Panchirova from the Czech Republic. And Jitka is a renal nurse originally, but has worked since 2006 in clinical quality and environmental management. She's giving this talk on behalf of the EDTA and ERA, where she has been active in many positions, also as president and executive director, but currently is a quality environmental consultant. And Jitka will give a talk on the nurse and multidisciplinary staff member perspective, which clinical and non-clinical processes in nephrology burden the environment.
Good afternoon, ladies and gentlemen. My presentation on behalf of EDTA ERCA is focusing on a green dialysis topic, and main objective of my talk is to highlight which clinical and non-clinical processes burden the environment. Renal replacement therapy has become a common treatment. However, increasing number of CKD patients with a consequent increase in the number of dialysis treatments can be considered as a current environmental challenge. Furthermore, dialysis treatment relies on the use of sophisticated active medical devices, disposable material, natural resources, and drugs. Good news is that multidisciplinary staff members involved in chronic renal care became more aware of environmental burden of dialysis and need to implement sustainable strategies and focus on life cycle approach. Due to the importance of the green dialysis topic, our association conducted a survey among volunteers from 21 countries. Here are just a few examples of the results we obtained. 87% of respondents confirmed that the implementation of a green policy is an important part of their daily life. The big surprise was when 35% of respondents said that they have waste management regulations in their countries, but they are often ignored by a majority of people. Respondents think that for reducing the environmental impact of treatments, it will be most appropriate implementation of green program, including reduce, reuse, and recycle concept, as well as digitalization, electronization, and proper waste separation, including education in this area. Key message from our survey is that the majority of respondents are not aware of green initiative of renal industry in their countries. Secondly, awareness for sustainability in daily life is higher than in professional activities. Let's focus on professional ones. It is well known that dialysis treatment is one of the natural resources hungry medical interventions. It is also necessary to keep in mind other non-clinical processes in renal care, because even during their execution are consumed natural resources, used chemical substances, and generated waste, emissions, and noise. Average water consumption is between 400 and 500 liters per one dialysis treatment. Average electricity consumption is between 10 and 13 kilowatt-hours per one dialysis treatment. Over 1 kilogram of hazardous waste is produced during one dialysis treatment, and this waste category is usually not recycled. Thrice weekly in Central HD has a carbon footprint of 3.8 tons CO2 equivalent per patient a year. The majority of emissions arise from medical equipment, energy use, and patient travel. Let's take a closer look at the water consumption. During 1 year HD treatment for one patient, the HD therapy requires about 78 cubic meters of water. Some of the water is lost in the technological process of water treatment and cannot be further used. Water preparation for dialysis is certainly one of the clinical processes that significantly affects the environment. Production of 1 liter of ultra-pure water for dialysis requires between 1.5 and 1.7 liter of raw water. It means that about 60 or 70% of water, depending on the type of water treatment system, is rejected. What is important, the rejected water is still potable and can be used for different purposes, like for windows and floor cleaning, car washing, dishwashing, garden watering, and so on. Every year, at least 100 millions of cubic meters can be saved if we reuse the water rejected by water treatment units only. Electricity is also an important natural source we consume during the execution of clinical processes. Another clinical process that affects the environment is disinfection. Heat disinfection of the loop as well as heat disinfection of the dialysis machines are the most energy-consuming processes during the renal replacement therapy. It is obvious that proper disinfection is needed to avoid the risk of infections, but we should reconsider which kind of disinfection is effective and makes sense from an economical point of view. The amount of hazardous waste per one dialysis treatment can be the easiest one to improve. In average, renal units produce between 1 or 2 kilos of hazardous waste per one treatment, depending upon the type of dialysis machine, disposable material for dialysis, and emptying policies. Proper waste separation, I mean hazardous, plastic, sharps, paper, and communal, and use of lighter disposable materials for dialysis can be directly translated into the cost savings. The financial cost of waste disposal is high and is mainly related to hazardous waste disposal, with costs ranging from 2.2 to 16 euro per session, depending on the waste management policy. Chemical substances and disinfectants are being used for the majority of clinical and non-clinical processes. Renal patients and multidisciplinary staff members risk exposure to disinfectants. The dialysis machine shall be cleaned and disinfected after each patient treatment or after every 72 hours break in working. Cyto heat disinfection of dialysis machines is a common standard. However, some dialysis machines can be still disinfected with strong solutions of hypochlorite or peracetic acid. Dialysis, with its high dependence upon technology, disposable material, and transport requirements, presents an unusual perspective for environmental management. It is not difficult to define a number of environmental aspects, which are elements of renal units operations and services that interact with the environment. In the case of clinical processes, most important aspects are hazardous waste generation, natural resources consumption, and use of disinfectants with the risk of spillage to the environment. Non-clinical processes like technical service, transport of patients, facility management, laundry and catering for patients also burden the environment, as we also need natural resources for their execution and waste emissions and noise are generated. The implementation of the environmental management system and ISO 14001 requirements, which has been already adopted by a number of hospitals and renal units, makes a significant contribution to renal care impact reduction. Benefits of the environmental management system are as follows. EMS helps to minimize the environmental incidents and environmental impact of renal units operations. Verifies that renal care business complies with the latest environmental legal requirements, saves money by driving down water and electricity consumption, reducing hazardous waste production, use of plastics, and hazardous chemical substances. Streamlines clinical procedures like emptying of bloodlines, dialyzers, and bicarbonate cartridges. Increase the profit from lower costs, and last but not least, supports innovation and sustainability because looking at the resources differently usually starts to see more possibilities. Several processes in renal care can be performed in a more friendly way. A good example is use of central A concentrate distribution. In average, 90% of dialysis fluid is water. Renal units can easily buy A concentrate as a dry powder and use mixing machine on site. There is no need to ship large amount of water around the globe. This procedure minimizes transport cost, use of plastic canisters, and CO2 emissions. In the example from the UK, we can see that the use of central concentrate distribution brings a certain carbon and cost savings. Bicarbonate cartridges are not considered in some countries like hazardous waste and can be redirected for recycling or to domestic waste. Plastic saline bottles, bags, and infusion lines can be also avoided and replaced by using online mode on dialysis machine. I also need to mention use of chemical substances and disinfectants. Hygiene requirements are not always compatible with green requirements. However, there are some possibilities like a green cleaning concept. Green cleaning means using cleaning methods with environmentally friendly ingredients and chemicals to preserve human health and guarantee environmental quality. Green disinfectants and cleaning products should be without chlorine, artificial colors, fragrances, and phosphates. Preferred products for green cleaning should be biodegradable. For degrees of environmental burden of dialysis is fundamental continuous staff training and education. All healthcare professionals should be aware that both clinical and non-clinical processes can be and should be improved. Proper use of standby mode on the dialysis machine and implementation of emptying policies make sense. Use of eco-friendly disinfectants and alternative materials to plastics is also gaining in importance. Please do not wait and implement these improvements into your daily clinical practice for the benefit of our planet and all of us. Thank you very much for your attention.
Thank you, Jitka Panchirova, for this interesting talk. And I now like to introduce Cecile Legallais, who is a research director at University of Technology de Compiègne. And you will talk about water waste and potential reuse in dialysis treatment. Please.
Thank you. So I just try to share my screen. Okay, I hope this is okay for you. So I'm very pleased to participate to this e-seminar. So in contrast to the two previous speakers, I'm not a medical doctor, I'm an engineer, and I think engineers and research engineers are already, do have also to take their place in this story. So I'm working, as mentioned, at the Technological University of Compiègne in France, and I will present today the work we perform with a PhD student, Annette Bruchfeld, who is from Morocco and who is supervised by Professor Husseini, who is in the service of nephrology of University of Fès in Morocco. And this work is also performed together with the technician Hubert Métayer at the local dialysis center we have in Compiègne, and together also with a colleague in process engineering. So the starting point from this work was really to also, as engineer, take into account that the device we maybe contributed to design, not build, but design at least at a certain step, are now highly complex. Of course, they are very helpful for the patients, but also there is some ethical issues that could be now considered with the use of such devices. I will not go in detail into this data because we already heard about that. And I will really focus today on the problem of the water need of this machine to perform treatment, as already mentioned, because as it was said, there is a lot of water that is used to perform the treatment, but also a lot of waste coming from this preparation. So the context of the study, in fact, came from this PhD student. As I said, he comes from Morocco, and in Morocco, you probably know that it's a semi-arid area that, and they are exposed to periods of water shortfalls during some periods of the year. And at the same time, they perform hemodialysis. There is an increasing number of dialyzed patients there, so it's very good. It's a positive point in terms of healthcare. But they consider in these dialysis units that they could suffer from this water starvation. As the COP22 was held in Marrakesh now 6 years ago, they proposed that there could be a study regarding the energy and water consumption associated to this dialysis unit, and that was a kind of starting point of their study there. And more recently, Ahmed joined me in Compiègne to perform some part of the work. And I realized that not only in these specific countries, it could be water shortfalls, but also in France. This is the map of this summer. In red, you have the places where irrigation was forbidden. And if you had the chance to travel in France this summer, despite all of the other problems, there was some parts really in the center, it was like deserts, really. So that means that not only the countries far away could be submitted to such starvation, it could be also our turn in Europe. And so that means that it's more than time to take care about that. Of course, if you look at the dialysis numbers in France too, there is a lot of patients, of course. They are spread into centers and very few at home, and they all also consume this water. So definitely we have to take this in charge in the Sustainable Development Goals, of course, and the question of water is of course very important. So why do we use so much water for the dialysis session? Because what most of the clinicians know, are aware of, is the dialysate preparation and the dialysate use for the treatment itself. And let's say that about the dialysate itself, it's about 150 liters that are wasted, that are used, of course, for the dialysis and for the mass transfer, but that are finally wasted and brought back to sewage per patient and per session. So then if you have already seen some counts about that, it's a very huge number of amount of water. But to prepare this dialysate, in fact, you have to start from the drinking water that is provided at the hospital. And this water needs to be prepared before being distributed to the hemodialysis monitors because it needs to be cleaned of any chemicals and microbial contaminants. So that means that this drinking water will be usually stored in a tank and then will be filtered with different type of filters. To reduce the hardness of the water, we use softeners. So that means salt will be added to make some exchanges and so on. And then, of course, all of these ionic compounds needs to be removed. So they are removed through a reverse osmosis technique, usually, that allows really to filter with very small pore size membrane that keep all the ions, and then you have ultra pure water that is then transferred to the monitors for the dialysate preparation. But in this reverse osmosis system, there is in fact the permeate that is going, so as I said, as ultra pure water, but there is also the concentrate, and the concentrate is rejected. The concentrate represents 30 to 60, 70% of the whole water that is used. So that means that there is about 250, sometimes up to 300 liters per session that are directly going to waste also. So they go to sewage too. So that means that finally for a dialysis session, you need about 400 liters. So if you count per year, it's and per patient, it's a huge amount of water. If you compare that to daily consumption, of course, they are different according to the country you are in. In France, we have a daily consumption at home that is about 150 liters per day. In Morocco, you see that they try to save the water already, and in US, not at all. So that means that these amounts are really significant. We cannot say, okay, it's not such much water. It's a lot of water that is really going back to the waste without any reuse or recycling at the moment, or almost nothing. So the aim of our study, as I said, as engineer, was really to ask ourselves how we can reuse or recycle this waste. So the way we took the problem is first to identify, or at least to know what is in this wastewater, then collect the standards and the regulation data that could be linked to the reuse process, for instance. We also conducted a survey about the practices that in the centers at the moment, and tried then to propose some solution. So there are two types of water that I wasted, the dialysate first, and in the dialysate, of course, you know that there is the uremic toxins that are there, but for other parameters, for instance, for the biological parameters, the data are very good. But in this dialysate, we have also the problem of what is transferred to the membrane, so from the blood of the patient to the membrane, so probably there are also drugs. I didn't find any data about that. So if some people in the audience have data regarding this, I would be very interested to have some knowledge about that. So that means that this dialysate is not probably the most easy water part to recycle, to reuse. if we look at the reverse osmosis concentrate, so that is rejected in the first loop, the content has been measured by different centers everywhere in the world, in Australia, in Morocco, and also some data that we can collect in France. The pH is okay, it's more or less normal pH. And what mainly we have in this concentrate is some ionic salts, which leads to conductivities that are in the range of 2 to 3 millisiemens per centimeter. So it's much less than the dialysate itself. And the main ions you will find there are sodium, chloride, and so on. So regarding the survey, I'm sorry this slide is in French, but I will not comment it too much. It's just to say that we sent the same survey to centers in France and in Morocco to get some feedback from that. And the first question were just to assess what are the type of center, which answered, and so on. And the middle of the part was a question regarding the reuse activity. And you can see that there is very few of them. That means that most of the centers, they don't do anything. They just release the water to the sewage. So first of all, we asked them whether they quantify this release of wastewater. And there is not that much. In fact, if you look, there is less than 30% of the centers that try to quantify it. When they do, of course, they find the figures we already showed. There is almost no physicochemical analysis of the rejection. So that means that they don't know what they put back, in fact, in the sewage. They don't reuse, most of them. There are more centers in Morocco that are reusing, and usually they use that for irrigation or cleaning, as already mentioned in the previous talk. We asked them if they have ideas for recycling or reuse, and so we find about the same answers. And what would be what are the others according to them for not doing so? And the answers are more or less well known. So that means the first hurdle is at the infrastructure. So that means the settings that are all around this water treatment units, they are not adapted for reuse of water. So that means if we want to bring this back, it will need some implementation at the hospital or at the centers that will need to do some specific work to adapt. Many people think it's too expensive, even if there is no data about that. And also some of them still say that they are not interested, that they have no time, or also they don't know the regulations, so they don't know how to implement it. We also collected some experiences from the literature. As I said before, in Australia, there was a very interesting work that is that you can have a look in this handbook that I put the link on the slides. And again, there is some very few reuse experience that we can really have as really documented. We were looking for standards and regulation. We have many regulations regarding healthcare system, medical devices, and so on. Regarding the reuse of water, it's much less clear. Of course, there are some standards sometimes or local regulation. We have some European regulation, for instance, regarding the irrigation of green spaces or for agriculture, for instance. But if you want to use the water in a rehabilitation pool, for instance, it's very difficult to find any data, but for the microbial contents, but for the other contents, there is not so many data and so on. And for sterilization, in fact, it's going back to what is known. So that means drinkable water or softened water. So we put back the data here just to show that regarding the conductivity, which finally is the most important parameters, you can see that the target is different according to the application. The most severe ones are dealing with irrigation and agriculture because you cannot release too much salt, in fact, in such water. But regarding, for instance, cleaning, it's not so, the constraint is not so high. But definitely there is too much salt in this loop, in the water coming out of this loop. So that means that you have to perform somehow desalination. And desalination is well known for other applications in process engineering, for instance, for seawater desalination in the countries where the water supply is not enough, and for which if they have money to put in these techniques, of course, because they could be quite expensive. And you have three major engineering processes that you can implement for salt removal. The first one is distillation, and so this is very powerful system, and that can go to large-scale production. So it's interesting, but it's not really adapted if you want really to remove salt that are at reduced concentration, because as it's high, there is a high demand in energy for this distillation process. Reverse osmosis, we know the technique because it's already in the loop, but there we should use it the other way around, which is not really the purpose of the system. And there is another technique that is electrode dialysis that I will describe a little bit later. It's interesting because for low salt concentration, so if the salt concentration is below 10 grams per liter, it's very interesting technique in terms of energy demands. And you can really, using this technique, remove the ionic contents that are considered as contaminants. So that means that would then allow the use of the water in different applications. There is another technique that is based on halophyte plants. So here it's a green technique. It's eco-friendly, of course, and it's also probably very cost-effective because you are growing plants. But we didn't have time to study such possibility in the framework of the PhD thesis. So that's why we really concentrated on the electrode dialysis technique. So this electrode dialysis technique relies on the use of ion exchange membranes that are located here. So it's kind of dialysis, but it's not based on concentration gradient. It's based on the charge that you will find on the membranes. And so that means that you will remove cations via the mass transfer with the cathode membrane, and you remove the other ions through the other membrane. So that means application of electric powder, of course, because you will make a potential electric potential difference, and due to this electric potential difference, the ions will migrate in the other compartment. So the purpose is to here we have the feed tank. So we want to remove some salt from this feed tank, and the ions that are removed, they will be concentrated in this concentrate tank, and you can play on the volume, for instance, the volume of the feed compared to the volume of the concentrate. So what we did in Compiègne is we did a parametric study to try to find optimal operating conditions and see whether really the technique could be applicable to the water that is rejected from the reverse osmosis loop. So we use for this the one that was produced at the dialysis unit in Compiègne. And really what we aim to do is to follow the fall down of the conductivity and then to see if it's feasible to reach the different standards or concentration that are the target concentration that are recommended by the guidelines or by the standards. So in any case, you will have a decrease of the concentration of the conductivity, so the concentration of all the ions in solution. And this decrease could be very fast if you have about the same ratio between the volume of the concentrate and the volume of the feed tank, so the one you want to clean. If you have a large tank, feed tank volume and a small concentrated tank volume, then you will take more time. But again, you will manage in a few minutes to decrease the conductivity of your volume of salt. So that means that depending on the application, so for instance, here we take the value, the target value that is in link with sterilization process, so water for sterilization. So we can see that to reach this limit, according to the operating condition, you will need a few minutes or a little bit more. But anyway, we have now the way to really perform scaling up of this system, because here it was, as you have seen, the lab scale experiment, but we use dimensionless analysis. It's our job as engineers, let's say, and we are now able to design and to give some hints on the size of the operating condition for larger volume to be treated. So just to end up with some also data regarding energy. Energy demand is quite low compared to what could be proposed in reverse osmosis. I remember that for distillation, the data are more about 15. So for reverse osmosis, it's slow, but the energy consumption that is associated with electrode dialysis will in fact depend only on the target conductivity you want to reach. So if you need to decrease a lot the conductivity, of course, the energy demand will be a bit higher, but you can see that still it's much less than the one from the other techniques. So just to summarize, we believe at least that our study is relevant in this context of sustainable development goals. Definitely, it's possible to reduce the volume of the waste, either using just reuse or using recycling. So that means pre-treatment before next use. What is interesting is that really the water that is rejected from the reverse osmosis has a really constant composition. We did several measurements at different times in the dialysis center in Compiègne. It's more or less always the same conductivity, the same composition. So that means that if you propose some protocols for reuse, they can be applied quite repeatedly without any changes. We suggest really to use electrode dialysis to perform this desalination treatment as efficient and cost effective. Really, the hurdles that we have to fight against is the absence of policy. For the moment, nobody is doing nothing. So the message is do it yourself. But to do that, that means to get information, of course, and then to work with the engineers that are in charge of the infrastructure of the buildings, of the biomedical engineers, and so on. And so what we would like to do as next step is really to prepare guidelines that could be transmitted to all the centers that want to implement such technologies, and of course also to the industry that will have to design and to make this electrodialysis unit. Another word that I would like to mention also is that, and it was also proposed by the previous speakers, is that of course we can try to reuse or to recycle, but maybe we should also think about reducing the volume of the water that is used, and specifically the volume of the dialysate. Do we need so much volume of dialysate to perform now treatment with the highly permeable membranes? It's a question we can ask ourselves. And another point, as already mentioned also, is really to work on this disinfection process, and probably here also there is a lot of place to avoid so much use of water. So thank you very much for your attention.
So thank you very much for this interesting and inspiring lecture, Cecile Legallais. And now I would like to ask the panelists to stay, and we have some questions for you. So first I would like to ask, we have from Eleanor Murray from the UK, is could we put purchasing pressure on suppliers of equipment to quantify their carbon footprints? There is in the UK the Carbon Trust Initiative, and their aim is to how can we decarbonate energy system and increase flexibility of these systems? How can we as professionals and engineers put pressure on these suppliers? So the question is up. Okay, Peter Blankenstein.
Well, at least one way could be is to define expectations or to express expectations with that in that respect. I think that many of our colleagues so far do not have clear expectations in this respect. And so that could be a first step towards the industries.
So, Jitka, do you have a comment regarding this?
Yes, I think it is really important to join forces between all renal professionals. I mean, physicians, nurses, technicians, other staff members, and actually present our requirements to industry partners. Because if there will be strong force from healthcare professionals, I think that industry should react on this.
Yes, and maybe to add to that, maybe that's also a role for the EDTA to liaise with the big industries on this subject and try to, well, work together in some way with the big industries to make progress in this field.
So this has all been extremely interesting. I have learned a lot. But I also like to mention that there is another opportunity that we nephrologists must engage in. And the EAT Landsat Commission showed 2 years ago that food is the single strongest level to optimize human health and environmental sustainability. So the global food production is responsible for more than 20% of all greenhouse emissions and 70% of all freshwater use. So what we really need for the future is a radical transformation of the global food system. And here I think, as nephrology is a nutritional specialty, we are good in nutrition, and we should take a lead here to try to see that we can do this radical transformation of the food systems. And we need to introduce and start to educate personnel and patients about plant-based foods, which should be good both for their health and for the environment. So there are different areas and in which I think nephrology can make a difference.
Yeah. Yeah, so sustainable health and sustainable health care.
Yes. And I also think, Peter, that your statements about the importance of education, because we really need to educate the next generations of medical doctors and nurses and other health professionals how important this is, so that is part of their DNA when they start their careers, that everything must be considered regarding its effect on environmental sustainability.
I think Cecile, you wanted to comment?
Yeah, maybe to come back to the first point, I think what could be important is really to have a global cost analysis, because when you speak about technical solution, for the moment, what we hear is okay, but it will cost more. So that means the industry doesn't want to implant, because finally they think they will not be able to sell the new system for water recycling, for instance. And so what would probably help, but it should be done maybe probably with economists, is really to have an idea of not only what is spent, but if we save that much of water, what will it mean for the, not one treatment, but for the global aspects. And if we have this kind of cost, then it will be much easier to convince than the biomedical engineers at hospitals, or let's say the director of hospital, that is good investment. And if they are convinced, then probably the suppliers, they will have to follow, because one or two will go there, and then they will have to adjust themselves to this. But this global cost, I think, is still missing, unfortunately.
Yeah. And what I think is really important, that this is a multidisciplinary problem. We really need to engage together, and doctors, we cannot do much if we don't get help from engineers and veterinarians, zoologists, biologists, anthropologists. Has a lot of aspects that we could benefit from. So we need to engage and communicate with other communities in this. The world's toughest problem ever.
Yeah. So I think what Cecile is referring to is this health economics and how this cost benefit will play out and who takes the lead. And I think it's a joint venture. We have to take the lead together. So there are a few questions in the chat. So a question from Jose Divino: green dialysis should also include peritoneal dialysis, or am I wrong? So I can say he's not wrong, but do you have any comments about peritoneal dialysis? I think it was, you have alluded to it a little bit on the panel.
Well, the review paper by the Australians I referred to in one of the slides actually summarizes the information on peritoneal dialysis, and that's very limited. And obviously, the nice thing of peritoneal dialysis is that there is no transport or very little transport of the patient to the center. But on the other side, there is this transport of water, large amounts of waters to the patient. So what the overall balance is, I don't know. I think that is the conclusion so far, that there's so little data that there's no clear conclusion.
Yeah, and the waste of the peritoneal dialysis, what can we do about it?
I see a really interesting question from Johannes Mann. I don't know, I'm not sure this will be possible to answer, but at least we can discuss if there are any data on successful implementations of green nephrology. Do we have a role model here somewhere in the world?
I think in Australia, they did really very good work on that. So I mentioned the report on water, but probably they treated also other aspects. So that's so it's far away, of course, but they probably are more, or at least in advance compared to us, to keep really their environment. So that's.
So is this a specific center, or is it in region, or the whole Australia, or?
It was in specific center, but I think it was dealing with some kind of region. I'm sorry, I'm not very familiar with Australia, so I will not say stupid things about that, but it was for me, it was regional study.
Yeah, this specific review paper was published by Catherine Berklau and John Agar. Catherine is based in Melbourne, I know, and she indeed summarizes Australian activities. But so I can't remember the details, but it could be of value to read that review.
Yeah. So I have a question. Of course, there are a lot of regulatory demands, but should we have environmental demands on public procurement of dialysis materials as like a new legal, in a new legal context? Would that help?
Yes. From my perspective, I would say yes. And indeed also include in any process of purchasing new equipment or new materials, have a discussion on circularity. What will happen with the materials, with the device, with whatever you are going to buy after usage? And presently, so we are in the process of buying a new reverse osmosis machine for our dialysis center, and I've tried to have this on the agenda, but the potential suppliers, manufacturers, there is so little information so far from them. It's rather disappointing, actually. So it's our role to define expectations and not being satisfied with vague answers. I think that's the start, and that could also be the role of the EDTA, of a European organization defining demands, expectations, etc.
Yeah, I think the example you bring up about the UK, these ambitious plans. I mean, I know that in Sweden we have also ambitious plans, but when it comes to procurement of dialysis solutions, they sort of forgot it. Yeah. And it's like from the political level, I think we have to work on the political level to to introduce this as a really important aspect.
Yeah.
So I have a comment from Alexandra Molano. Greetings from Colombia. This is not a question, but to mention that we are reducing dialysate with very interesting results in water saving. Thanks for the amazing meeting. So this is an example that it is possible to do this. And I would like to ask Peter in this regard, what are your ideas about these new medium cutoff membranes that should be able to be used instead of hemodiafiltration? Is that the way to save water?
Yeah, I don't know. So you mean that you obtain the same result with less water usage?
Yes, that is. I wonder if that is right.
Good question. I think so far nobody really knows, but that could be an hypothesis. Yeah, indeed.
Yeah, as engineer, I was always surprised that there was no change in the, let's say, flow rates that should be applied, because the membrane, they change a lot. The technology improved, and we are still with the date or the operating condition that was fixed in the 60s, maybe 70s. And we know that the membrane are much less permeable, so probably the mass transfer are much quicker. So, and
yeah.
Then who is able to perform such studies? Because if you lower the flow rate, then that means you will also lower the amount of concentrate you are using to produce the dialysate. But you could be on the, if we follow just the regulations, the companies can state, okay, but then you do not respect our recommendation and you do not perform the treatment as you should. So I don't know how you can perform this with patients. Finally, that's.
Yeah, well, that's a very interesting point. So in the standard, hemodialysis is performed usually with 500 milliliters of dialysis flow per minute. But if you ask yourself where this 500 milliliters is based on, actually, I don't really know. And I've seen 1 or 2 studies trying to find out whether a slightly lower flow, for instance, 400, will produce an identical result. So an identical clearance, a removal. And so if that is the case, so that could be already a smaller use of water, indeed. Yeah, a lower use of water.
So I see a raised hand, and this is Dimitros Stamatalis. And I don't know if you can come in live or if I should read your question. Is it possible for you to connect and ask it yourself? If not, I read it. It's on the chat. There are also studies for implementation of portable systems with dialysate regeneration using sorbents. There are also companies developing sorbent cartridges for that. This is also relevant for peritoneal dialysis. The current therapy uses single pass dialysate, which also wastes lots of water. Is there any comments maybe from you, Peter, on this?
Yes. Well, I happen to know Dimitrios. Yeah, so it's really encouraging that there are initiatives in this respect, trying to find out whether there is methodology to overall reduce the environmental impact. So I don't know of any comparison, but at least that there is efforts to do that is really encouraging.
So I would like to, there will be one other question about that right away, but I would like to bring up the question of the patients, because we do all this because of the patients. My experience is that it's also important to bring in the patients in this kind of equation, because there's no reason to think that they are not interested in these questions they will be interested in these questions as well. And I also am very hopeful for the young generation, because they teach us things about the environment. So I think it's important to team up with the patient organizations when you have these discussions on a regulatory level and with the politicians, and they will have an important input, and most of them don't want to waste energy or water, and they want to be healthy, but they will look forward to sensible solutions in this area, and you should contact your organizations and work with them.
Okay.
I have an important question here from Kate Stevens. Do you think there is an apathy for green nephrology? How do we overcome this? How do we keep enthusiastic? Because there are so many depressing news all the time. So how do we keep the momentum for green nephrology?
Yeah. Well, I have tried to briefly touch upon that with respect to motivation. As it started as a professional motivation, and I've shown you this Landsat paper and this primum non nocere concept. But gradually, for me, there was also this personal motivation that, as I mentioned, with this picture with my grandchild, we have a clear responsibility, which we cannot deny. But apparently not all people feel the same responsibility, but then it's our task to repeatedly mention that and come forward and maybe stand on the barricades, become an activist, or whatever method that can help. At least that is my personal view.
Just a testimony on my side, because as I said, I started working on this 3 years ago, more or less, because of this PhD student coming to us. And now that we have some results, I had the chance also to communicate in France, first in front of the young nephrologists, and they were very enthusiastic. I was surprised, in fact, because I thought that we were working on our own on this, and I didn't see so many publications and so on. And then I had access to the, let's say, mother society, the French Francophone Society for Nephrology. And also now there is a working group on this. So maybe we started later in France, but let's expect that then we can push a little bit if necessary in some cases. And there is really, I think people just realize it takes time, but I'm not sure it's apathy. That's
no. And what I find personally especially encouraging is that, at least what I see here in the Netherlands, that younger people are becoming increasingly active, and then students in the medical field over the past 12 months or so, there's an absolute increase in activity. And actually, in several universities here in the Netherlands, students are sending messages to the deans of the university. Hey, Mr. Dean or Mrs. Dean, we miss certain aspects in the curriculum and the sustainability. So, and I'm pretty convinced that this movement will grow. At least that's what I see.
Jitka, do you have any comment about in the nursing world how these discussions are developing?
I would like to react also on a previous topic, and I would like to say that we have certain processes defined in renal care, and what is also important for hospitals owners is cost of dialysis treatment, and we know that the number of dialysis patients is increasing and the treatments are becoming more and more costly. And I would say that what is also important is to define proper procedures and processes in renal care, because you can do that perfectly in regards to patient, but less perfectly in regards to environment. And I think that we can actually do that perfectly for both, also for patients and for environment, because on one example, like waste management, there are several clinics which educated staff in proper separation of waste, and it looks like a peanut to save half kilo of waste per one dialysis treatment. But if you multiply it by number of treatments, by number of patients, then you may get 20,000 euro per one dialysis center a year, which means that also economic effect should be somehow actually presented to healthcare professionals, because I think that this is also important, not to just waste actually natural resources, but also money.
Yes, very, very true. Yeah.
I see another question from José Divino. Several randomized trials with convective therapies have shown that outcomes are better as the convective volume increases. Should we save on well-being of the patients in order to have more environmental sustainability? That is
That's a
question moral.
yeah. Okay. The question is for everybody. Yeah.
Okay. Anybody?
Mm.
Well, I think that most of us, maybe all of us, are not prepared to compromise on quality. So I think the overall aim should be is targeting the best quality for our patients with the lowest level possible of environmental burden. So that could be, yeah, difficult in some areas and not so difficult in other areas. Yeah.
I think the example that Jitka brought up about the waste, I mean, that doesn't compromise the effectivity of the treatment, and also how to manage water. There are things you can do, still do.
Absolutely. No, and the whole water discussion, and that can be done without compromising quality. May I ask a question to Cecile? There's some suggestion that dialysate, so used dialysate, could be used as a fertilizer in gardens or something. Do you have real data on that? That's just, I heard somewhere a vague suggestion, because there's nitrogen and things like that in the water.
Yeah, but the used dialysate, it's a really high salt content. So I'm sure that for the gardens, it just will kill your green.
No, but actually the tomatoes become sweeter if you use salt water.
Okay.
So
yeah, it could be helpful, probably. No, I think we should really decrease the salt concentration. For the dialysate, the used dialysate, I'm really wondering when we will analyze what is really in, especially as mentioned about drugs and so on. There is not very few studies, but there are also changes during the dialysing process. And I'm really wondering when some authorities will have a look at that and see what is really rejected. That's I'm surprised that there is no studies about that.
Well, I do remember a presentation by Greek investigators from Patros a couple of years ago at the EDTA meeting, and they told us, or they showed a poster, that orange trees which were watered with used dialysate grew better than those watered with regular water.
Okay.
I don't know whether that is published. I have not been able to
maybe we should try.
Yeah.
You know.
Some gardeners say that some plants really like if you take half urine and half water, that they will grow much better. So
True, yeah.
this is something that we should study.
Yeah. But that necessitates collaboration with other really, well, non-medical people, like engineers and people who are familiar, agricultural people.
Yeah.
So let's see, we have maybe some more questions. This is a very difficult questions, but we can still try to answer. This is Mohammed Aserai who asking how to evaluate the carbon print of dialysis machine factories.
Yes, these estimations of the supply chain, so the scope 3 type of environmental burden, I have tried to understand the methodology. For instance, in this report of on the global carbon footprint, there is an addendum of 100 pages or so explaining the methodology. And also to this Landsat paper, there is an addendum of, I don't know how many pages, but they explain the methodology. And I have to say that is a little bit too complex for me to explain today. But it seems to me, at least it is presented as accepted estimations. So I suppose, well, one could say that this kind of methodology is a specialty in itself, which I'm not an expert in.
Okay. We have to wrap up in a few minutes, and so there's a final question, I think. This is from Rame Miftari, who says, congratulations for very good presentations. My question is, what would be the recommendations for countries with weak economies and low income to solve these type of problems? And that would be a question, sort of final remarks from all of you.
Yeah. Well, my personal view, but that again, that's a personal view. If you look at this per capita carbon footprint, then you see that all the Western countries are the top polluters. So I think it's our duty, our task to take the initiative and to progress in this field. But that's my personal opinion.
Okay.
Yeah, it's we try to work on a low-cost dialysis machine with a non-profit association organization here in France, and I have to say it's very complicated because you have these big companies. They don't want you to go in this way because they want to sell their machine and all the systems that are going together. So even though probably the cost even of the device of the machine itself could be reduced, there is no economic interest for them. So and then you really think you have to fight again the system, and if you don't want to make profit, then you don't have the ability to get the CE mark, to obey all the regulation, and it's very easy to catch your legs for that. So that's
yeah, it's an upstream battle, you mean?
Yeah.
Okay.
So Jitka, what is your view on this?
Yes, I would like to say as a final recommendation that really what makes sense is streamlining of clinical and non-clinical processes and procedures, and also implementation of environmental management system, because it is so easy to say we need a lot of water, a lot of electricity, we generate a lot of waste by dialysis treatment, but if there is no proper system in place, I mean, if we do not monitor, measure, analyze, and improve processes, then actually we may do these processes more costly, and we can create a higher environmental burden of dialysis than needed. So I would say this is really a task for multidisciplinary staff members, because even cleaning lady using wrong disinfectants can influence burden of dialysis.
Yes.
Okay, it's getting close to the end, and I would like to end by citing what Dimitrios Stamatialis wrote on the chat. Thank you all for fine talks and discussions. And I would really like to thank you also, the speakers, and for this discussion. And I hope really that this will be something we will discuss much more in the future, because there is an urgent need, and I think there is a lot of competence within nephrology that we should use for the advantage of planetary health.
Yes.
Okay, so
Okay.
thank you for attending all.
Thank you.
Thank